in the last slide how to deduce the empirical formula of ethanoic acid in order to give us the simplest whole number ratio of atoms of each element within that compound. Where for ethanoic acid, this simplest ratio was 1 carbon atom to 2 hydrogen atoms to 1 oxygen atom. We can now start to think about how empirical formulae can be really useful in calculations. The empirical formula of a compound gives the simplest whole number ratio of atoms of each element in that compound. We can calculate the molecular formula of a compound using the empirical formula and the relative formula mass, or MR value. Let's think about how we might do that by looking at an example. Compound Z has an empirical formula of C2H4O, and the MR, or relative formula mass of Z, is 132. The question is, find the molecular formula of Z. The important point here is that we know that the empirical formula is the simplest whole number ratio of the atoms of each element that are present within that compound. Therefore, looking at the empirical formula tells us which atoms are going to be present and their relative ratio. And we therefore know that the molecular formula has to be some multiple of this empirical formula. We can use the relative formula mass of the compound as well as the relative formula mass of the empirical formula to work out what we need to multiply the empirical formula by in order to get the molecular formula. The first step in the process is therefore to calculate the relative formula mass, or MR, of the empirical formula, which is C2H4O.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make chemistry at GCSE a walk in the park.